Okay, so hello and welcome back. So let's do a couple of examples, see what we have here regarding all the theory that we did with these inverse trigonometric functions. So we said that, so let's go through example number 1. You want to find the principal value of sine inverse. You want to find the principal value of sine inverse 1 over square root of 2. Okay. So we said that the principal value of an inverse trigonometric function, the principal value of an inverse trigonometric function is the value of the inverse trigonometric function is the value of the inverse trigonometric function that lies in the range of the principal branch. That lies in the range of the principal branch is basically that lies in the range of the principal branch of the inverse trigonometric function. So the principal value of an inverse trigonometric function is the value of the inverse trigonometric function that lies in the range of the principal branch of the inverse trigonometric function. And we argued that, for example, if you think about, for example, the Cot Inverse Function. If you think about the Cot Inverse Function. So the Cot Inverse Function, basically what it is that this is the Cot function. This is the Cot Inverse Function. And when you take when you basically create the inverse of that, of the function, basically you'll essentially get some function like this, in which, of course, all of these branches will be, of course, reproduced in the inverse function that you have here. But there is a branch that we denote as the principal value branch of the function, because, as you can see here, the range of this branch is the restricted domain of the original function, and the domain of this inverse trigonometric function now is the range of the same branch, right? So which means that, for example, I could go and restrict, for example, the domain of this function to, since I have basically y is equal to cot x, I can go and restrict the domain of this function to, for example, negative pi to 0. If I do so, basically what happens is that then the range of the inverse function would be negative pi to 0, which would essentially give me this part over here, and then the the domain of this would be the range, which is basically R here, and I would get basically this function over here, right? But and then for example, if I were to calculate using basically this part of the function, if I were to calculate basically f inverse of, or whatever, cot inverse of 1, for example, I would get basically this value over here, this value, right? Now, if I restrict the domain of this function to 0 to pi, then the range of the function that I will get would be 0 to pi. And then what that means is that then the cot inverse of 1, for example, in that case would be this value over here. If I restrict the domain of this function to pi, from pi to 2 pi, then the range of the function becomes pi to 2 pi, and then therefore the cot inverse of 1, for example, would be this value over here, right? Depending on what you do here, the range will change, right? Because the domain is changing here. And so what that means is that when I'm looking for the principal value of the sine inverse of, for example, whatever the value might be, I have to basically go and see what is the definition that we had. And the definition that we had was that basically we had the sine function, and we said that we would basically now I cannot see that all of that in my mind yet, but the graph is always there, of course. So we said that basically we would restrict, in the case of the sine function, we said that basically we would restrict the domain of the function to negative pi by 2 to pi by 2. In that interval, basically your function is 1, 1 and onto. So that means that the range of the function becomes negative pi by 2 to pi by 2, and basically then the domain of that function becomes basically negative 1 to 1. So negative 1 to 1, negative 1 to 1, and then that would be basically, that would be the domain, and the range would be negative pi by 2 to pi by 2. That is basically the domain and range of the sine inverse function. And that's basically what we got in the table that we developed in the previous video. And now I can use this definition in order to, otherwise I could do any other thing for that matter, meaning that I could go in and say that, okay, I want to take I want to restrict the domain of the function to pi by 2 to 3 pi by 2. In this interval, the function is still 1, 1 and onto. So pi by 2 to 3 pi by 2, since over there that is the domain of the function, then here becomes the range of the function, pi by 2 to 3 pi by 2. And then again the range of the range would be the same thing. So here I will get the same thing as negative 1 comma 1, and then this would be again the sine inverse function. But the problem here is that based on our definition, this is not the principal. This is not the principal value branch of the function of the function sine inverse, right? So I cannot use this, right? But this function over here is the principal value branch And since the question is asking the principal value of the function sine inverse, I have to use this one. And so now let's answer the question. Let's answer the question now. Okay, so now in order to calculate the sine inverse of 1 over square root of 2, the sine inverse of 1 over square root of 2, in case you're not familiar with this ratio, this is the same thing as if you write, basically if you write 1 over square root of 2, that's the same thing as 1 over square root of 2, and then I can multiply the numerator and denominator by square root of 2, I will get square root of 2 over 2. And you know that basically sine of 45 degrees, or sine of pi by 4, sine of 45 degrees, which is equal to sine of pi by 4, is equal to square root of 2, right? So if I say that sine of pi by 4 is equal to square root of 2, that means that sine inverse of square root of 2 by 2 is equal to pi by 4. Right? So which means that now you need to make sure that this input is of course in your domain. So square root of 2 over 2 is some value, like for example 1.4 divided by 2, which is 0.7. It is in your domain. And pi by 4 is basically some value in your range, because basically pi by 4 is 45 degrees. Over here you can go from negative 90 degrees all the way up to 90 degrees, and pi by 4 would be some value over, so this is negative pi by 2, and this is pi by 2, and this whole thing over here is your range. And your domain is basically, I cannot show the domain here, but the range is basically between negative pi by 2 and pi by 2, including both of those values. Which means that now pi by 4 is some angle right over here. This angle over here is pi by 4, which is the same thing as 45 degrees. So then I can say that since basically the input of the function is allowed in the domain of the function, and the output is in the range of the function, I can say that the sine inverse of 1 over square root of 2, which is the same thing as the sine inverse of square root of 2 over 2, that is equal to pi by 4, which is equal to 45 degrees, right? So that is the first question. And of course it is important to understand these things, because otherwise we will get to more advanced topics like calculus, and over there you need to be able to analyze each and every one of these situations. Otherwise then you will not be able to answer other questions that are asked based on these questions, based on these concepts basically. So, and then the way that they have solved this problem in the solution is that they have said that basically since we want to calculate the sine inverse of 1 over square root of 2, then you can write basically let sine inverse of 1 over square root of 2 be equal to y, right? And then what that means is that sine y is equal to 1 over square root of 2. So we know that the range of the principal value branch of the sine function, the range of the principal value branch, the range of the principal value branch of the sine inverse function is what? Is the range is basically negative pi by 2 to pi by 2, right? Is negative pi by 2 to pi by 2. And we also know that basically the sine of pi by 4 is equal to 1 over square root of 2, which is the same thing as square root of 2 over 2. Therefore, the principal value of the principal value of sine inverse 1 over square root of 2 is the same thing as pi by 4. So the range of the principal value branch of the sine inverse function is negative pi by 2 to pi by 2, and we also know that the sine of pi by 4 is equal to 1 over square root of 2, and since here over here we said that sine of y is equal to 1 over square root of 2, therefore you can say that y is equal to pi by 4, or sine inverse of basically sine inverse of 1 over square root of 2 is equal to pi by 4, right? So pretty simple, but it's all simply just definitions, nothing very nothing very complicated about it, but then you need to use your logic and analyze the situation and then simply solve the problem. The next question that we have, we want to find the principal value of cot inverse negative 1 over square root of 3. So we want to find the principal value of cot inverse 1 over square root of 3. Now, cot over square root of 3 is something that you need to calculate. First of all, the cot function, you need to know the domain and the range of the function, right? Of course, it's not really necessary. Well, it is of course necessary. So the cot function is basically, this is the cot function, which is supposed to be cot of x. And we said that basically you can see that I have an asymptote here. And this is pi by 2, and then at pi, again, I have another asymptote. So we said that, I suppose, as far as I can remember, I think we took we restricted the domain of the function to negative pi by 2 or to pi by 2, if I'm not mistaken. Or no, 0 to pi, I'm sorry. 0 to pi, right? So if I restrict the domain of this function to 0 to pi, then basically then the other those cases were for the secant and the cosecant function. So if I restrict the domain of this function to 0 to pi, then of course the the function is going to be 1, 1, and onto, then I can find the inverse of the function. Now, to find the inverse of the function, since I have basically restricted domain to 0 to pi, then the range becomes 0 to pi. The range becomes 0 to pi. And the domain becomes R. So R to 0 to pi. And I'm saying R because over here you can see that the range of this function is R. So, and therefore the domain of this function becomes R, and this is the Cot inverse function, right? So this is the principal value branch of the Cot inverse function. Now, if I say that basically the Cot inverse of basically 1 over square root of 3 is equal to some y, for example, then that means that basically cot of y, for example, if I say that basically, and of course, in case we haven't talked about this, what this means is that basically suppose that I say that, for example, the sine of 30 degrees is equal to 1 by 2, right? So what that means is that basically if I have some angle over here, some 30-degree angle over here, this 30-degree angle over here creates a triangle in the unit circle, and in this triangle this angle is 30 degrees, and of course you know that this angle becomes 60 and this angle becomes 90 degrees, right? Now the sine of 30 degrees, if I take this value as this length, if I take it as A, and this length if I take it as B, so by the definition of the sine function, we said that sine is basically opposite by hypotenuse, which means that basically the sine of 30 degrees is the length of the opposite side, which is A, divided by the hypotenuse, which is B, right? So when you have the sine function, over here you will have an angle, and over here you will have a ratio. Over here you will have a ratio of side lengths of a right triangle. Which means that the sine function basically it accepts an angle from you, and it gives you the ratio of the side lengths of a triangle in which that angle lies, or in which that angle lives, right? Which means that the output of the sine function is always some ratio between 0 and 1, or between -1 and 1, meaning that some value like 0.5, 0.7, 0.8, or -0.5, -0.8, and so on and so forth. So that's what the sine function does. It accepts an angle from you, and it gives you a ratio. On the other hand, the sine inverse function is the inverse of that function, meaning that the sine inverse function, it accepts the ratio from you. Suppose that you don't know the angle, you have that ratio, right? suppose that you know that ratio, you give that ratio to the sine inverse function, and what it will give you is basically the angle, right? So these are inverse processes. In the what the sine function does, it accepts the angle from you, gives you that ratio. The sine inverse function accepts the same ratio from you, and it gives you back the angle, right? So what that means is that when I write, basically based on this situation, when I write cot inverse of 1 over square root of 3, 1 over square root of 3 is a ratio, right? That means that there has been some angle, and I have calculated the cot of that angle. Let's call that angle x, for example. There has been some angle, I have calculated the cot of that angle, and that ratio has been 1 over square root of 3. And now I want to know what that angle is, right? Based on this situation. So what that means is that basically then you need to know what angle gives you the ratio 1 over square root of 3 using the trigonometric function cot, right? So 1 over square root of 3 is the same thing as, I can write 1 over square root of 3 as basically 1 over square root of 3 and multiply by square root of 3, and it will give you square root of 3 over 3. So this is the same thing as square root of 3 over 3. Now, I know that basically cot of x is equal to square root of 3 over 3. Now, cot of x is the same thing as sine of x. It's the same thing as cos of x over sine of x, and that is equal to square root of 3 over 3. So now, if this must be either 30 degrees or 60 degrees. There is no other possibility. That I know based on the table in trigonometry that I have learned before. There is no other way really to tell it, and it cannot be any other angle really. So if you go for example 30 degrees, if x is equal to 30 degrees, or you can say pi by 6, right? If x is equal to 30 degrees or pi by 6, we know that the sine of pi by 6 is equal to the sine of 30 degrees, which is equal to 1 by 2. And we know that the cos of pi by 6 is equal to square root of 3 over 2, right? Which means that the cot of pi by 6 is the same thing as cos of pi by 6 over the sine of pi by 6, which is equal to basically square root of 3 over 2 over 1 by 2, which is equal to square root of 3. So this is not what I'm looking for. I see square, I get square root of 3 over here, and this ratio is square root of 3 over 3. So let's see what we get for 60 degrees. So for 60 degrees, if x is equal to 60 degrees, or which is the same thing as pi by 3, right? Pi by 3. So what that means is that I know that the sine of pi by 3, which is equal to the sine of 60 degrees, is equal to square root of 3 by 2. And also I know that the cos of pi by 3 is equal to 1 by 2. Cos of pi by 3 is equal to 1 by 2. That means that the cot of pi by 3 is equal to the cos of pi by 3 over the sine of pi by 3, which is equal to basically 1 over 2 over square root of 3 over square root of 3 over 2, which is the same thing as basically 1 over 2 times the reciprocal of this, which is 2 over square root of 3, and that's the same thing as 1 over square root of 3. Now 1 over square root of 3, you can write it as we saw over here, you can write it as square root of 3 over 3, right? So that means that this basically the cot of x is equal to square root of 3 over 3, and that is equal to, based on this, I can say that it is equal to basically the cot of pi by 3. The cot of pi by 3. And therefore you can say that, and therefore based on this you can say that basically x is equal to pi by 3. But of course you need to check whether the input outputs are within the ranges of our, within the allowed ranges of our domain and range, meaning that in the Cot inverse function I can enter any value that I want, as long as that value is in this is basically belongs to the set of real numbers. So 1 over square root of 3, of course it's a real number, I can enter it into this function, I have no problem. What I've gotten over here is pi over 3, which is some value between 0 and pi. Basically this pi is 180 degrees, this is 60 degrees, so we have no problem. And therefore you can say that the principal value of Cot inverse of 1 over square root of 3 is equal to pi over 3. And that is basically your answer there, right? Now there is only one problem here, and we were actually supposed to find the Cot inverse of negative 1 by square root of 3, which is a completely different angle, which is a completely different ratio. So, but that's not the problem. We will keep this as it is, and then we will do that as another example, right? Okay, so now let's ask the question again. The same question: what is the principal value of cot inverse negative 1 by square root of 3 this time? So we have the principal value of basically cot inverse negative 1 by square root of 3. Now in order to answer this question, again, the Cot inverse function, the domain and range, the Cot inverse function, we said that the domain is the set of real numbers, and the range is basically 0 to pi. 0 to pi, right? And in order to find out what angle we had, so that what angle I need to have in order to calculate the Cot inverse of negative 1 by square root of 3, I can simply write the Cot inverse of negative 1 by square root of 3 is equal to basically some y, for example, y being some angle, and this is a ratio. And so what that means is that now over here, what we said was that basically the cot of pi by 3 is equal to 1 over square root of 3. we said that the cot of pi by 3, which is the same thing as the cot of 60 degrees, the cot of 60 degrees is equal to square root of 3 by 3, or to be basically to write it the way that they have written it, basically 1 over square root of 3, right? Now, basically, the problem is that this number over here, so this is the cot of pi by 3 is equal to 1 over square root of 3, and this is the cot inverse of negative 1 by square root of 3. So this is negative 1 by square root of 3, this is 1 over square root of 3. Now the problem is that this is negative 1 over square root of 3, and this is 1 over square root of 3, which is not the same thing, really. Now, now what we need to do is that we need to find some way to figure out, based on what we know here, which is basically the cot of pi over 3 is equal to 1 over square root of 3. We need to know, based on this, we need to be able to somehow decide what angle I need to have so that the ratio of the cot of that angle becomes negative 1 over square root of 3, and that's possible based on the unit circle. You see that the cot function is nothing but the cot of x is equal to cos of x over the sine of x, right? Now, the cot of this angle pi by 3 is equal to 1 over square root of 3, which is a positive value, which means that if the cot of some angle is supposed to be a positive value, either so when you have a positive value over here, what that means is that to express that in terms of a ratio, either you have positive by positive, which gives you positive, or you have negative by negative, which gives you positive, right? Now, if a ratio becomes a negative value, then you have either a negative divided by positive or positive divided by negative. Which means that either, since basically I'm looking for basically some trigonometric ratio which is a negative value, I have to go basically into some quadrant in which either, so basically we said that the cot function is cos by sine. So either the cos of x is negative and the sine of x is positive, which is this first case over here, the sine of x is positive, or you can say that basically the cos of x is positive and the sine of x is negative, right? So how can I find that quadrant? So cos of x negative, sine of x positive. So cos of x over here is negative and sine of x is positive. That is the third quadrant. And if I say that the cos of x is positive and sine is negative, that's the fourth quadrant. Right? Which means that basically and now I need to decide in which quadrant my angle is going to be based on the fact that the cot of that angle is basically -1 by a square root of 3. So cot of x is equal to -1 by a square root of 3. Now, basically that angle, now we need to basically take a look at the unit circle. And if I have some angle, for example, so what we usually do, we find angles in terms of some angle in the first quadrant, and then we can basically make some changes to the angle which happens to be in the first quadrant, and take the angle to the second quadrant or the third quadrant or the fourth quadrant, or alternatively, if you have some angle in the fourth quadrant, you can express it in terms of some angle in the first quadrant, right? So now I don't really know where my angle is. What I know is that my angle is either in the third quadrant or in the fourth quadrant, but I don't know where it is, right? But what I do know is that basically the cot of pi by 3, which is basically 60 degrees, so this is 15, 30, 45, and 60. This is 60 degrees. I know that the cot of this angle is equal to 1 over square root of 3, and the cot of the angle I'm looking for is -1 by square root of 3. Now, if I have some angle over here, in the third quadrant, which is, for example, let's say 180 degrees, which is, let's say, for example, 180 degrees more than, for example, more than the angle that I have here. Let's suppose that is the case. Right, so if I have this angle over here, so that's 180 plus 60, which is equal to 240 degrees. This is 240 degrees, right? So 240 degrees is basically some angle. Now, let me actually do the unit circle in a proper way so that we can actually work with it. So let's say that this is your unit circle, and let's say that this is a circle that you draw here, and now what I'm going to do is I'm going to go and select the border, and let's say that this is your unit circle, okay? Now I'm going to show you the same thing using the formulas that we have as well. So let's say that you have some angle, for example, over here, 15, 30, 45, and 60 over here. And I know that the cot of that angle is equal to 1 over square root of 3. So this is basically, this is 60 degrees, right? Now let's suppose that you have some angle in the third quadrant right here, and that is basically 240 degrees. And 240 degrees is basically 60 plus 180. Which means that this angle is 180 degrees more than the angle that we have in the first quadrant, right? So if I calculate the sine of this angle, and the sine of this angle, you can see that you can tell that they are the exact same values. And the cos of this angle here, and the cos of this angle here, and the cos of this angle here, you can say that they are the exact same values, right? The only difference here is that the sine and cos of this angle are both positive, which means that the cot of the angle becomes positive. But over here, the sine and the sine, basically the sine over here, your cos is negative, sine is negative, and therefore again the cot would be a positive value, which means that I have made a mistake over here, right? I want my cot to be a negative value, but having the exact same absolute value as 1 over square root of 3. So that means that this whole discussion was actually useless, right? But that teaches you something, right? So I erase this unit circle, and I have to, of course, erase these two, meaning that the third quadrant doesn't work for me. Maybe the fourth quadrant is going to work, but let's see about that. So I draw a unit circle again, and I go over here and draw a circle over here. So select the border, and I draw a unit circle again, and then I have again my angle, which is 60 degrees, 15, 30, 45, and 60. And so I know that my angle is not in the third quadrant. And what that means is that over here my angle is the sine is positive, the cos is negative. The sine is positive, the cos is negative. That is actually the second quadrant. That is actually the second quadrant. Or in the fourth quadrant we have the sine is negative and the cos is positive, which means that you are in the fourth quadrant. So you're either in the second quadrant or in the fourth quadrant. Let's start with this one. Now, I'm going to be looking for some angle whose sine and cos values, the absolute value of the sine and cos values of that angle, is exactly the same as the sine and cos values of this angle, which is 60 degrees. So I need to basically draw this angle here. So this is basically 60 degrees. So I need to start from this line and go up 60 degrees, meaning that I have basically 15, 30, 45, 15, 30, 45, and 60. Which doesn't seem right. 15, 30, 45, and 60. Right? So now this angle is, well, I can call it negative 60 degrees. This angle is 60 degrees. And so if this angle is 60 degrees, that means that this angle is 30 degrees, which is 90 plus 30 is equal to 120 degrees, which means that this angle is actually 120 degrees. Now, since this angle is 120 degrees, now the point here is that basically your angle, if you take a look at this angle, you can see that basically the sine of the two angles are actually the exact same values. This is the sine of this angle, and also the sine of this angle. They are the exact same values. The cos of this angle is the absolute value of the cos of this angle is this length on the horizontal axis. The cos of this angle is again this length on the horizontal axis. The absolute value of them are exactly the same, so that must be the angle I'm looking for, which is 120 degrees, right? Now, over here, what you can see is that the angle that I have, which is 60 degrees, the cot of that angle is 1 over square root of 3. Now, the sine of the angle 120 degrees is exactly the same thing as the sine of the sine of the 60 degree angle. The cos of that angle has the same absolute value, or the same value, except basically not basically ignoring the sign, but it has an opposite sign, meaning that this cos value is positive, this cos value is negative, right? And what that means is that that this angle is actually whatever the value of the cot of this angle, which is 60 degrees. This angle is going to have the algebraic opposite of the cot of that angle, meaning that I can write if the cot of, for example, pi by 3, which is 60 degrees, is equal to 1 over square root of 3, which is what we knew from before, then of course the cot of 120 degrees is equal to negative 1 over square root of 3. This is deduction by construction, right? And it's a completely legitimate way of deducing and concluding things in mathematics. There is no problem. There is no logical problem with that. Now, what is basically 2 pi by, what is basically 120 degrees? 120 degrees is the same thing as 120 degrees is the same thing as, if you want to convert that to radians, you know that basically pi radians is the same thing as 180 degrees, right? So now what is 1 radian, or what is 1 degree? 1 degree is the same thing as, if I divide 180 by 180 in degrees, is the same thing as pi divided by 180 in radians, right? Which means that 180 by 180 is equal to 1 degree is equal to pi by 180 in radians. So which means that if I can write this as 120 degrees times, meaning that if 1 degree is pi by 180 radians, then 120 degrees is 120 times pi by 180 times basically in radians. Of course, I need to, or let me actually do set up a proportion. I can set up a proportion as basically 1 degree is the same thing as pi divided by 180 in radians, which means that then what is now 120 degrees? 120 degrees, if I take this as x, then I can cross multiply here, meaning that x times this is equal to this times this, which gives me x is equal to basically 120 times pi divided by 180 divided by 1, all in radians, right? Which is the same thing as 120 times pi divided by 180, all in radians, 12, 18, 6, 3, 6, 6, 2, 6, 3, which is the same thing as 2 pi by 3 radians, which gives me basically which means that basically 120 degrees is the same thing as 2 pi by 3 radians, right? Which means that I can write, based on what we discussed here, which means that I can write the cot of 2 pi by 3 is actually equal to negative 1 over square root of 3, right? Now I could show you the same thing using the formulas that we have, but that would take a long time. If we get the opportunity, we will do that as well, okay? So what that means is that now I know that over here, I know that the cot of 2 pi by 3 is equal to negative negative 1 over square root of 3. Negative 1 over square root of 3. Which means that basically so over here I'm saying that the cot of basically negative 1 over square root of 3 is equal to y, and I know that the cot of 2 pi by 3 is equal to 1 over negative 1 over square root of 3, which gives me which gives me y is equal to, which means that the cot inverse of basically negative 1 over square root of 3 is equal to 2 pi by 3. 2 pi by 3, right? And that is basically the angle that we have, but the only thing is that we need to make sure that basically the angle is actually that the domain and range of the cot inverse function are being used properly. So over here the domain of the cot inverse function is the set of real numbers, which is this number is a real number, there is no problem with that. And the range is supposed to be 0 to pi, which is this angle is nothing but is some angle between 0 to pi. You have no problem with that, and so you can say that basically the principal value of so you can say that basically the principal value of basically the cot inverse of negative 1 by square root of 3 is equal to 2 pi by 3. That is basically what we were looking for. Now, one thing that you can do on your own is that you saw that over here we had some 60-degree angle, and we saw that basically the cot of that angle, the cot of 60 degrees was equal to 1 over square root of 3. And we saw that there was some angle in the second quadrant, which was 120 degrees. 120 degrees was over negative 1 over square root of 3. And you can of course always find the third angle in the fourth quadrant, which is this angle over here. And this angle is of course this is 3 times 19 is equal to 270 plus 30 is equal to 300 degrees, right? And you can argue that the cot of 300 degrees, you can argue that the cot of 300 degrees is also equal to negative 1 over square root of 3. And the reason for that is that very simple. You can see that the value of the cos of this angle is exactly the same as the value of the cos of 60 degrees. The value of the sine of this angle is this value over here, which is exactly the same thing as this value. Of course, the signs being ignored for now. Now, the cos's are the same. The sine over here is positive. The sine over here is negative. That means that if the cot of 60 degrees is equal to 1 over square root of 3, then the cot of 300 degrees would be negative 1 over square root of 3, because the cos has the same sign, but the sine has different signs. And then based on that, you can basically come up with some formulas for yourself, meaning that you can say that, for example, I'm not going to go through this all the way through, but I'm just going to give you some ideas. Meaning that you can say that, for example, you can say that, for example, you can see that, for example, 120 degrees. Let's take this 60-degree angle as theta. Theta is equal to 60 degrees. And let's take this 120-degree angle as some other angle that I want to find in terms of theta. So that is the same thing as 180 minus theta. So 180 degrees minus theta would be equal to 120 degrees, right? And here I know that based on this construction, I can say that the cot of basically 180 degrees minus theta is negative of the cot of theta, right? And then you can use some formulas in trigonometry in order to figure that out, meaning that we already talked about all of those formulas in terms of basically the sine of for example a plus b. We had basically the sine of x plus y. We have the sine of x minus y, and we had the cos of x plus y. We had the cos of x minus y. So we calculate, we found out that, for example, this was sine x cos y plus, for example, cos x sine y, right? And we found out that this was basically again the same thing, sine x cos y minus cos x sine y, right? Over here, what we said was that this was cos x cos y plus minus sine x sine y, and over here we said that this was cos x cos y plus sine x sine y, right? And then, for example, then based on this, you can say you can basically derive some formula, meaning that cot of, for example, x plus y, for example, or cot of, let's go for cot of, let's see what is cot of x plus y based on these. Cot of x plus y is going to be equal to cos of x plus y over sine of x plus y, right? And then you can simply write this as cos of x plus y is equal to cos x cos y minus sine x sine y, and then sine of x plus y is equal to sine x cos y plus cos x sine y. And then there is always something that you can do, meaning that you can always, for example, divide by something to simplify your ratio, which is basically, for example, I don't know, divide by cos x cos y the numerator and the denominator, and then you will get some formula for this. And then using that formula, set x is equal to 180 degrees and set y is equal to, for example, theta, and see what if you will get basically the exact same result that we got over here. And moreover, based on what we said here, we can say that again, you can see that 300 degrees is the same thing as basically 360. This is 360 degrees, and this is again the same angle as theta, right? So this is 60 degrees. So I can also say that the cot of, for example, 2 pi minus, for example, theta is the same thing as negative cot theta, because cot theta over here is this is theta 60 degrees, cot of theta is equal to 1 over square root of 3. And if I want to write this angle 300 degrees in terms of theta, I could write it as 2 pi minus theta, right? And so what that means is that 2 pi minus theta is basically, well, 360 minus 60. This angle is actually 60, as you can see by construction. And 360 minus 60 is going to give you 300. And you can see that the cot of this angle is actually the algebraic opposite of the cot of this angle, but they have the exact same values, right? So then that is another basically relationship that we found here, and you can verify it using all of these formulas. So then you can basically, in the same formula that you find here, of course you have to find this formula for basically cot of x minus y, for example. You can do the same thing and find some formula here. And then you can set, for example, x is equal to 2 pi, and you can y is equal to theta, and see if you can get this formula as well, right? So there is a whole bunch of things that you can do in mathematics, and the whole of mathematics has been, for the most part, the whole field, wherever you go in mathematics, basically mathematics has been driven by most of the time, it's been driven by people who had a passion for mathematics. They just like to do something in mathematics, work with mathematics, or find out different things in mathematics, and so on and so forth. And then most of the time they didn't even think about the applications, because there was no way back then, for example, when the person was thinking about all of these abstract concepts, there was no way to think about the applications of mathematics. But then we talked about, for example, probability. The theory of probability was developed around 100-200 years ago, but then today it's being applied in, for example, quantum mechanics, for example, right? Or many other concepts in physics, really. Many other concepts in physics would not be really possible without all of the concepts that we have developed in mathematics. And mathematics usually don't really know anything about what they're doing. They just do it, and then they will happen to be used in some field, in some other branch of science, really. So that's how it works. Now, I'm going to end this video here, and in the next video we will talk a little bit about exercise 2.1. So I'll see you in the next video, and thank you.